Welcome, ladies and gentlemen, to the public forum of the Hydrogen and Fuel Cell and Batteries Group exhibit here on Hannover Fair. I would like to welcome you all to a very interesting topic because we want to talk about emission-free flight. Is that vision or is it reality? I would like to give you high five. It's only HY4, but it's even better, I would say. It's about HY4 project, and for this, I would like to welcome here on stage the director of the Institute for Energy Conversion and Storage of the University of Ulm, and at the same time the head of Energy Systems Integration of the Institute of Technical Thermodynamics at the German Aerospace Center, Professor Dr. Josef Kallo. Here he comes. Please give him a big hand. Professor Kallo, it's a pleasure to have you here on stage. And you're all invited to participate in this talk. If you have a question, just raise your hand. I'll be with the microphone right with you. So let's start with the Institute of Technical Thermodynamics of the German Aerospace Center. It's a research institute in the field of efficient energy storage and energy conversion systems. The same topics that you have at the University of Ulm as well.
Yes, right. So at the Institute of Technical Thermodynamics, I'm responsible for the group of Energy Systems Integration, which is a group which about 15 scientists. And our focus there is to promote and to bring fuel cell systems and battery systems together. So we have a very high efficient hybrid system. At the same time, at the University of Ulm, we have research on power electronics for hybrid systems, and also we have research regarding motors, electric motors, with a very high power-to-weight ratio. So in this case, we have a very good synergy between power sources and also power sinks.
But you're not only doing theoretical studies and basic research, but you also develop whole systems and operate pilot plans and applications. And the HY4 four-seater aircraft is one of them, isn't it?
Yes, right. So the HY4 is a very good example for how the University of Ulm and the German Aerospace Center can work together, in this case in a scientific group. And in this case, the HY4 will have space for 4 passengers. We'll have a hydrogen tank, which something around 9 kilograms of hydrogen. And then we will have a fuel cell system and a battery system from the German Aerospace Center, which will be coupled with the power electronics and the motor from the University of Ulm.
You know, Professor Kallo, it's so exciting to talk on a day where everybody is talking about electromobility, that is in the air already. So that's really the next step, isn't it?
That is very exciting. So at our institute, we have a lot of groups working also on mobility on ground. And our application, as a very small one, now is working in electromobility in the air. But I think we need that coupling between air and ground transportation. So we call it something like intermodal or multimodal traffic applications.
And we also need the integration of batteries and fuel cells. Most of the systems are hybrid. That's quite normal. Even in cars, they're all hybrid. They all need a battery. Especially also in air, it's also a hybrid system. So you have a fuel cell system that runs the motor in normal speed and cruise speed, and you have a battery for, well, the extra power you need for taking off and for gaining height, isn't it?
Exactly. That's how it works. So the strength of the battery is to deliver high power. And the strength of the fuel cell is to deliver energy for a long time. So this combination and a very efficient combination of those technologies, they lead to a very sophisticated but also very advantageous system for applications in the aircraft part.
Very interesting. We have a little movie which is coming up right now. You can have a look at it, how it looks like, and also, of course, you can look at a model of this aircraft just over there at the booth of DLR. But have a look at the movie. It's quite nice, and it shows you some features. But we continue talking about it, Professor Kallo. So, how fast can you fly with that aircraft?
So the aircraft concept we have today was developed with partners as Pipistrel and Hydrogenics, and also with other partners. And this led to a plane which has a decent velocity, cruise velocity of around 140 to 160 kilometers an hour. And the maximum speed, cruise speed, is around 200 kilometers an hour.
That's when it's coming down, or when you can gain the speed, 200 kilometers?
No, that is the cruise speed during cruise. So when it's coming down, so the never exceed speed is higher than that, so the plane is safe. But we are using the maximum high speed of around 200 kilometers an hour.
All right. And what is the range of this aircraft? How far can you fly with it?
So the range depends on the technology, storage technology, which we are using for the hydrogen storage. So first of all, we have the pressurized hydrogen with 350 bars, which is, I would say, common technology, which we used in the DLR H2, so the former project, but also which is a technology which was used in a lot of applications before. In a second application, so in the second phase, we have improved hydrogen storage systems, pressurized. We can increase the range of about 30% due to the baseline. And then we have also a technology which uses liquid hydrogen tanks, when we can achieve something around 1,500 to 1,800 kilometers range.
But state of the art in the mobility sector is now 700 bar pressurized. Well, we already have some refueling station for 700 bar. Will you go to that, or do you think you need the liquefied hydrogen?
So at the moment we have very good talks here on the fair with 700 bar manufacturers, and I'm very confident that we can go to 700 bar technology, but in phases, in steps.
And the range with 700 bar, could you say how far would that be, the range?
So the range with 700 bars would be something like 1,000, 1,100 kilometers in that range, maybe 1.15.
Which is enough for every flight within Germany, at least, you know.
Yes, definitely.
Okay, very good. So I like very much the design. It's really striking. It has two fuselages with two cabins. Why did you choose this kind of design?
This is very pragmatic, I would say. So the plane was built by Pipistrel in like 4 years ago, and it was developed for a battery, huge battery with 500 kilograms of battery. And so for us it was important this plane flew with the battery, and it's common technology. And it has a very high payload, which we can use for the fuel cells, but the battery, but also for hydrogen storage, and to have 4 passengers, so 4 people on board. So we went the very easy way, and we took a platform which is available, and we used that platform to build up the propulsion system. So our focus now today is to have a very reliable hydrogen battery hybrid propulsion system. And I would say the next 3 years we will have this plane as a platform. We will have long flights, we will have high endurance, we will have maybe also flights with a lot of starts and takes off and landings to test the technology. And then beginning in 3 years, I think we will build up a new plane which will be very, very nearby to a product.
Okay, that's again, exciting, but I could imagine with this kind of design, with two fuselages, you can't transport just one person or, let's say, 3 person, because it would go to one side, wouldn't it?
Oh, no. This plane is safe to be used with 1 person, with 2, with 3, with 4. So you can put the persons either on the left side or on the right side. Maybe it depends on
that doesn't matter, okay.
Yeah, it depends on the pilots, but you should have 1 captain on board. So
okay, one of them is a captain at least, yeah, of course. Very good. If there are any questions from your side, just raise your hand and you can participate in this talk. If you want to know some further details from Professor Kallo, just ask him. He's here for your questions, or for mine, of course. Professor Kallo, I think an airplane run by fuel cells is a wonderful example to show the reliability of the technology, because you can't afford a breakdown of a fuel cell system in the air, not at all.
Yes, right. So this is one of the major tasks. So our first goal will be now to implement a fuel cell which has a redundant system with a battery in a first phase. So in the first phase, we will show that the functionality of the fuel cell in aircraft application and also in altitude is there. But then we will have a second phase, which is very important for the aircraft application, which leads to a very reliable fuel cell system. So that will be a development phase in the next 1.5 to 2 years. But if we achieve that, then we have a very reliable and also aircraft system. This is very important for us also, because then we can take this system, we have a very good knowledge about the system, and as it is a modular system, we can use those modules and recombine very easily that system to put this system in a car application or in a forklift application, maybe also in a stationary application.
Or even in a bigger plane. Do you think also about bigger planes?
Yes, bigger planes are, how should I say, on German...
I wouldn't say a jumbo, but maybe with 8 person.
So bigger planes means a lot of investment. What I can say from today's perspective, 8-seater, maybe a 10-seater airplane with, let's say, 400 kilometers an hour. It's just a question of money and time. So, as I said it today before, the physics are with us. So we understood how to deal with the fuel cell, how to deal with the materials, and so on. So I think this is only it's a case of money and time. If we go to bigger planes, I would say the maximum vision to be used with a fuel cell is something around 40-seater electric aircraft. That is the edge of the feasibility which we can see today. If we have a bigger plane from today's perspective, I would say it has to be a gas turbine or an internal combustion engine, but a gas turbine hybridized with a battery. And then I think we can go also to 100 to 140-seater. Everything which is bigger and has a range, let's say 5,000 kilometers plus. From my technological perspective, I would say has to be an optimized turbine plane. So there is a lot of work to do in each development part.
Which could be a turbine that runs on hydrogen. That's also possible, huh?
So, running a turbine of hydrogen, I think there was a Tupolev 1555.
It was indeed, yeah, in 1988 already.
Oh, perfect, yeah. But it was an experimental aircraft which was built by the Russian company. So it would be a very exciting project to work on. So I'm not bonded to the fuel cell part, but I will be very careful with how to build it and if it's feasible in a day-to-day perspective, from a day-to-day perspective.
I can even remember the turbine. It was from Rolls-Royce, and they were very far. They built it in Aachen, and they were very good at it, actually. Yeah, they showed it here at the group exhibit, let's say 20 years ago. So it's quite a long time that that airplanes are in the air running on hydrogen. And also, you showed one here on the group exhibit Hydrogen and Fuel Cells in 2010. That was the DLR H2 motor glider you presented here.
Yeah.
How were your experiences with that one?
So that experience is the baseline which we are using today for the HY4. So that was for us the first step to show that it is possible to fly with it. So we had a very good cooperation with Lange Aviation, which was the builder of the air motor glider. And we had also a very good cooperation with Hydrogenics and also with the motor manufacturer. And based on that, we learned that building up modules which are more powerful, which can work under altitude and aircraft conditions, are feasible. And I would say this now is the second phase, which shows it's possible to have a higher payload, it's possible to have more range, and even now we know those baselines which we learned will apply in every plane which we will have. So it was a very interesting and very, very good experience.
I learned this week from Mrs. Merkel the saying, the proof of the pudding is the eating, and the proof of an airplane is the maiden flight. When will be the maiden flight for the HY4?
This is something which is a little bit sensitive, because we have to show first that it's technically feasible and it flies safe, and that proof will be, I would say, not in a couple of months, but in a couple of weeks. And then officially we will have the plane, I would say, at the end of the summer in September as an official event shown in a country or in a town in the South German part of the Republic.
Could be your home city probably, which is Stuttgart. So maybe.
So if you look at the sponsors or if you look at the partners and you see the airport of Stuttgart, then you can imagine that there will be something there. Yes.
Okay, we're looking forward to that. And then you really have a pre-commercial product. You really think about it, really to bring it into the air and let's operate it as an electric air taxi. That could be possible, isn't it?
So that is a concept when we are thinking about putting the plane into let's say, into a business case. So the plane has a range of around 1,000 kilometers, but it flies at around 200 kilometers an hour. So this is the first step. Now the point is using that plane for 5 hours. I'm a pilot myself, and I can say to fly a 5-hour small plane, it's a little bit boring. So you don't want to have the passengers flying like 5 hours on that. But the point is, with that range, we can take like 100 to 200 kilometer legs. And based on that, we can say we fly for 45 minutes, for 30 minutes, for 1 hour, and we connect like a town of Stuttgart with a town of Aalen or Friedrichshafen, which by car or by train, it takes like 2 hours to go from Friedrichshafen to Stuttgart, but it takes like, by train, but it takes like 37 minutes to go by plane.
You probably should think about northern Germany, even if you're situated in Stuttgart, because they are the little islands, you know, and to get from Hamburg to one of the Frisian islands, that takes very long because you have to use the ferry. So many people fly there and would love to fly this short distance, which are not more than 100 kilometers, with an, well, emission-free air taxi.
Yes,
maybe that's another business case.
In that region, yeah.
Very interesting thing. And at the same time, you would have a business case for all these unused airports in Germany. We have so many airports that are almost unused.
Yes, that's right. So we are thinking about Germany, but let's think about a little bit bigger. So in Europe, at this time, we have something around 1,200 airports in total, which include airports which have a runway more than 600 meters. So we need a runway around 600 meters to take off and land. And these are spread out over Europe. So now we have the ACARE-Ziele, which the European Union told us we have to be in 4 hours from door to door. Now imagine starting in northern Portugal. By car it takes you like, or train it takes like 3 hours to go to Lisbon. From there you take the plane, and then, so the huge plane, and then you can fly like in 2 hours from Lissabon to Stuttgart. That's fine. And then it takes you by public transportation like 3 hours and 15 minutes to travel from Stuttgart to Waldürn, which is 130 kilometers away. So now we could have those connections
directly, yes.
Like a multimodal transportation, which we can switch very easily from one transportation method to the other.
Professor Kallo, very exciting. We run out of time. I'm sorry, I'm always late. I have really to apologize to my colleagues who are waiting here for the next interview on stage. But I would like to invite you to visit the booth of DLR just over there. There you can see a wonderful model of the HY4, and also talk to Professor Kallo even more, and maybe also about this spin-off he's founded, H2Fly. So there's something more to explore in this business case. I would like to thank you very much, Professor Kallo. It's quite exciting. I wish you good luck for your maiden flight. Thank you very much for your attention.
Thank you.
Thank you. And we proceed with the program here on stage with the next interview at 4 o'clock with Nick Kallman, Technical Business Development Manager of Dana Holding Corporation, about thermal management of fuel cell, battery and high power electronics and battery electric vehicles, hybrid electric vehicles and fuel cell vehicles. So please stay tuned. We start here in a minute.